We are back again, but this time we are doing the momentum in terms of graphs. So here we are given a graph and we are given some information about it. So let's read the information first and discuss the graph here. It says a car of mass 1200 kg moving to the right collides with a stationary motor of mass 800 kg. So before we go to the questions, let's discuss what's going on here. So this car here of mass 1200 kg was moving to the right. It was moving to the right. That's why here we have a positive 24,000. Or here we have a momentum and here we have a time. So this is momentum versus time graph. So it's y versus x. So we know that momentum is measured in kg per meter per second and the time is measured in seconds there. So what's happening here is that this car here of mass 1200 kg was moving to the right with a positive velocity. Why do I say positive velocity? Because they chose to the right as their positive direction. That's why they have a positive 24,000. So at this time here, it's 1 2 3 4. So the scale, you can see the scale, you can follow the scale here, and this scale is in 8,000. So it's 8,000, 16,000, 24,000, and so on and so on. So the scale here is correct, you don't have to worry about it. So at 2 seconds here, it collides with a stationary motor of mass 800 kg. So the collision, how long does the collision take? So the collision takes from 2 seconds to 4.7 seconds. So how long does this collision take? So to find out the time that the collision takes, you just say 4.7 minus 2, which would be 2.7. So the collision takes 2.7 seconds. So after the collision, this car of mass 1200 kg has a velocity, has a negative momentum. What does negative momentum mean? It means that after colliding with this motor, it now moves to the left. It no longer moves to the right, but it moves to the left. Remember that someone might ask, why doesn't this graph go this way then, if it is moving to the left? Remember, guys, that time is a scalar quantity. So we do not have a negative time. Time moves forward, it does not move backward. So when this line here skips the positive y-axis and coming to the negative y-axis, it means that the object has changed directions. It doesn't move to the right anymore, but now it is moving to the left. That's why we have a negative momentum here. So I think we discussed enough here. We said that it was moving to the right with a momentum of 24,000, and after colliding it moves to the left with a momentum of negative 8,000. So let's go straight to the questions. The first question says determine the initial velocity of the car before collision. So if you don't mind, I will answer here. It's 1.1. I will answer here 1.1. We have the momentum, we have the mass, so we can calculate the velocity using this equation here, formula here. The momentum is equals to mass times velocity. So what is the momentum? Is 24,000. 24,000 is equals to, what is the mass? Is 1,200 kilograms. Remember that this graph here shows the motion of only the 1,200 kg mass car here. It doesn't show the motion of this motor here. So that's why we don't have two lines here, we have only one line. And to find the velocity, we divide both sides by 1,200 yes times v. So velocity is what's my calculator? Let me look for my calculator. Okay, I found my calculator. I think we can continue now. So I'm gonna say 24,000 divided by 1,200. I get a value of 20 here. So the velocity is 20 meters per second. What is the direction of the velocity? Of course, to the right, like this here. So that's number one. So how do we let's go to number two. Let me bring it close so that we can see. It says here 1.1.2 determine the final velocity of the car after collision. So after collision, it has a momentum of negative 8,000. So let's answer 1.1.2 here. So it's 1.1.2. Here is 1.1.1. Here is 1.1.2. So we are going to use the same formula. P is equals to mv. We have a momentum of negative 8,000 is equals to 1,200 times velocity. So what is velocity? We'll get a negative velocity here. So it's 8,000 divided by 1,200. So I get a velocity of negative 6.67, negative 6.67 meters per second. You cannot leave your answer like this, so you must quote your answer. If you get a negative answer, you must say velocity is 6.67 meters per second to the left, like this here. So after colliding, let me make an example. So after colliding, this is the 1,200 kg car and this is the motor. So after colliding, this car will collide with the motor. The motor will move to the right and the car moves to the left, like this here. That's how we have a negative velocity. And let's look at 1.1.3. It says determine the velocity of the motor after the collision. Determine the velocity of the motor after the collision. So what are we gonna do here? Of course, we are gonna use the principle of conservation of linear momentum. So to answer 1.1.3, we're gonna use the conservation of the total linear momentum. It's m1 v1 initial plus m2 v2 initial is equals to m1 v1 final plus m2 v2 final. It says that in an isolated system, the total linear momentum remains constant. As long as you do not have friction, then the momentum will remain constant. So let's fill in the missing variables here. So what is the mass of the car? Let's say the car is m1 and the motor is m2. So the mass of the car is 1,200. What is the initial velocity? We calculated it here. It's 20 meters per second. We are choosing to the right as positive. So let's plus, what is the mass of the motor? We are given there as 800. So plus 800 into 0, because it was initially at rest, it was not moving, and after the collision this car moves to the left. So I'm gonna say 1,200 into negative 6.67 plus 800 v. And yeah, let's say 1,200. Let me do it here. 1,200 plus this here will be 0. So we can bring this to the other side, would be minus 1,200 into minus 6.67. Let's get the answer for it. We get an answer of 9,204. So we're gonna take this 9204 and divide it by 800 to get the final velocity. It's just a simple algebra that we can do. So divide by 800, not 8000. So I get a final velocity of 11,51. So the velocity of the motor after collision is 11,51 meters per second. Because we got a positive answer, then we will say to the right, because we chose to the right as positive. And that's it about 1.1.3. And another way of doing it, you can see here, you just write the formula first, and then you, since you're already given the momentums here, we can just say 24,000 plus 800. We are not given the momentum of the motor, so just say 800 times 0 is because, don't forget to write the formula first before you substitute. So we are gonna say, what is the final momentum? Of course, it's minus 8,000 minus 8,000 plus 800 V. So we're gonna say 24,000. This will multiply to 0, so we can bring this minus 8,000 to the other side and it becomes positive 8,000. So we get an answer of 32,000. Then we can divide this answer by 800. Divide by 800. So we get a velocity of 40 meters per second. So V is equals to 40 meters per second. 40 meters per second. But why are my answers not corresponding with each other? Did I make any mistake here? Let me check. I think I did make a mistake here, because these answers must be the same. Let me recheck. I think I did a mistake. So let me see. 1,200 into, I am sure you saw the mistake, but trust me, I didn't see the mistake. Let me verify then. And minus this will come to the other side, and it will become minus 1,200 into minus 6.67, and let me divide this by 800. I get an answer of 40. Yeah, I did do a mistake here, because this velocity cannot be 11, it will be 40 meters per second to the right. The reason I didn't get 40 straight is because I converted here. This is 6, the real answer is 6,6666, continue like that, but I converted it. That's why I didn't get 40 straight. If you spotted the mistake, let me know in the comment section what I did wrong here. And yeah, let's continue. And what is another question? Determine the, we are on 1.2 now. Determine the average force that the car exerts on the motor during the collision. So how do we determine the force? We know that the car will come with a force, and the motor must also exert the same force, but in opposite direction, according to Newton's third law of motion. So let's calculate that force there. So we said that force is equals to changing momentum over the change in time. But here we are looking only at the car. We're not looking at the motor, we're looking at the car. But we'll do it in two ways to show you what I mean there. So let's fill in the missing weights, the missing variables here. So the change in momentum, we know that is the final momentum minus the initial momentum. So final momentum is minus 8,000. Initial momentum is positive 24,000. So how long did the collision last? The collision lasted from, it started from 2 seconds to 4.7 seconds. So the collision lasted for, you can say 4.7 minus 2. It lasted, or you can just substitute in 2.7. It doesn't really matter. So you're gonna say minus 8,000. Let me do it here. Minus 8,000 minus 24,000 over 4.7 minus 2. So it's minus 11,000 minus 11,851.85 Newton. 0.85 Newton. And but right, I know they asked us to calculate the force that the car exerts on the motor, but I want us to calculate the force that the motor exerts on the car. I told you that we'll get the same value, but here we'll get a positive value because a motor exerts a force on the car and the car exerts a force on the motor. You can refer to Newton's third law of motion. Let me answer it here. Another way, this is option 2, is changing momentum over the change in time. So it's equals to the initial momentum of the car, the final momentum of the car, we can calculate it by saying 800 into, let's say it was, we calculate the velocity, of course it was 40, it's 40, and minus the initial momentum, it was at rest, so we'll put 0. The change in time will be 4.7 minus 2, or you can just say over 2.7. So let's calculate the momentum. It's 800 into 40 plus 800 into 0, which we can say 4.7 minus 2. We get the same answer, but this one is positive. So it's equals to 851.85 Newton. We get the same answers, but in opposite directions. So let's look at the last question. It says, oh no, it's not the last, it's 1.3. So let me answer 1.3 here. 1.3. I hope the camera can show there. Let me move this here. And 1.3, it says calculate the impulse of the force during the collision. So how do we calculate the impulse? I know that here we are using most of the formulas, and let's try using the gradient of this formula here, of this graph here. So during the collision, we can use this triangle here to calculate the impulse. No, we cannot calculate the impulse here, but we can calculate the force, because the force says the change in y, which is the change in momentum over the change in time. So it will give us the force. You could have used the area of this triangle here too. You will get the same answer of this here. Let me show you that. So it's half of, the area is half of base. What is base? Our base is, it will be 4.7 minus 2, which is, let's say 4.7 minus 2, which will be the base of this triangle here. So times the height. What is our height? Our height, of course, it's 40,000. We will say 24,000 minus negative 8,000 minus negative 8,000. So it's minus negative 8,000, like this. Sorry, let me Okay, let me fix it. Okay, I forget about this for now. I think I'm missing some important thing, but I will fix it. Trust me, I will fix it. And calculate the impulse. We can use the F net times time. So we can say the impulse is equals to F net times the change in time. So the impulse is, we calculate the net force, so we can say the impulse is negative 11,851.85 times, what is the time during collision? Of course, is 2.7 seconds. So the impulse will be 11 minus 11,851.85 times 2.7 gives us a value of negative 32,000. So the impulse is negative 32,000, like this. Of course, I will confirm the impulse using the gradient formula here. I will confirm that, but for now let's continue with the rest of the question. I think I'm missing something important here, but I will fix it, trust me. So the last question here, is this a collision elastic or inelastic? Prove your answer by performing necessary calculations. So we have to determine whether this collision is elastic or inelastic. So in the previous video, I showed you how to compare this here. So I'm gonna say 1.4. I'm gonna say EK initial is equals to half M1 V1 squared plus half M2 V2 squared. Initial is equals to, let's substitute here, half of the initial momentum of the car, which is 24,000 times the velocity. Let me substitute the mass here is 1,200. Sorry about that. So the velocity, we calculated it to be 20 plus half of 800, but because initially it was at rest, so it will become 0 here. So the initial kinetic energy of the system is half mass of 1,200 and times 20 squared. So I get a value of 240,000. 240,000 joules. So let me do the EK final in here. The EK final. And the EK final, we can substitute in what we know. It's half of 1,200. What is the final velocity? Of course, it's 6.67 squared. The reason I didn't substitute in the negative sign is because even if I substitute negative, this square here will cancel that negative there. So it's not necessary to put the negative sign there. Plus half. What is the mass? Is 800. What is the final velocity? I'm gonna squeeze it here. So the final is 40. And to find the kinetic energy final, we're gonna see 1,200. Sorry, is half of 1,200 into 6.67 squared plus half of 800 into 40 squared. So what is the kinetic energy final? It's 666. Let me write it here. It's 666 693.34. So we have a kinetic energy of 666,693.34 joules. Remember, it's measured in joules. We started with a kinetic energy of 240,000. We ended up with a kinetic energy of 666,000. So therefore, this collision is inelastic. Like I told you in the previous video, we don't have elastic collisions in real life. We only have inelastic collisions. I hope this video was helpful. So make sure you subscribe and tell your friends about this channel, because we are learning here. We do not stop learning. We learn every day. So I will see you in the next video. We will be doing the exam question. I will take random question papers and do them with you on momentum. So I will see you in the next video.